Well, good evening, everybody. Thank you for coming. We'll open just with a short word of prayer here. Thank you, Lord, for being able to have this opportunity to gather together tonight. You've told us where there's 2 or 3 or more together in your name, then you're in the midst of us, and we're confident that you'll do that since we are gathered together in your name. We praise you for your creation, and as we continue walking through it, learning more about it, and reaffirming, hopefully, our faith in you and your word. And pray for those who are listening at home that they might be touched and moved as well. In Jesus' name we pray. Amen. All right, well, this is the 4th session, and I'm only going to cover one section today because there's just simply too much for me to have done this, especially since I'm going to delve a little bit into the flood geology a little bit later. Excuse me. Just to review, we've covered the introductory section was on just the importance theologically and even the believability of the creation account. The science is probably more, it's improbable that evolution could have occurred when you put numbers to it. And we talked about what the general science community believes and how they treat the nut jobs of creationists, but anyway. And then we started going from the smallest, and we're going to end up in the biggest, and then actually we're going to end up with the best, which will be the Word of God in the very last section. But we covered quarks and atoms, the smallest things that supposedly occurred in those first 1/40,000th of a second after the supposed Big Bang. We talked about how with string theory, to try to explain the mathematics behind that, there was actually 7 extra dimensions necessary to explain that. And that number of 7 extra dimensions, there's plenty of, it would seem like there's room for God's different supernatural actions to be in that. We covered then what I thought was the second session was the 3 and 4 here, which I think was the most convincing because it was so lends itself to the mathematical underpinnings of the molecules, the DNA, the RNA, the Krebs cycle, the cells, the things that just, the numbers that we presented were just incomprehensibly improbable for them to occur. Last time, a couple of weeks ago, we covered what I called life to man, or the journey to man, where we went from what it would take to go from amoeba to man, so to speak, and going through the classification system. And then we covered just some other real design features and showing the complexity and the improbabilities of many other just kind of random animals along the way. So tonight we're going to cover the geology, Earth and geology. And I'm going to definitely stipulate, I've got an MD after my name. I'm not a geologist, and this is going to be probably the hardest one for me to relate to because it's really not up my alley, but I've done a lot of work on reading on it, and there's really great, I was talking to somebody earlier today, there's great resources online, and YouTube, what have you, that if you've got a geology tilt, you can find things that are much more comprehensible and comprehensive than what I'm describing here today. But we're going to cover this in a short bit on the fossil record again, things about the young Earth features, and then some design. And as I say, we're going to try to cover in a little more than superficial detail how the flood really explains some of these things. I'll remind you some of these general broad principles that we've covered over the previous sessions, that wrong assumptions or biases commonly will lead to wrong conclusions. I was thinking if there's any country music fans, that the night the lights went out in Georgia, wrong assumptions led to wrong conclusions, right? So anyway, then there's the hierarchy of, shall I say, uncertainty in science. We want to stay to the left-hand side of this, the facts, the provable theories, and the principles, and kind of stay away from the hypotheses, thoughts, and opinions. That's the sort of source for a lot of extra posts online or even books that get caught up and picked up by the lay media and kind of are probably, in many times, more confusing than they really are contributory towards understanding things. Another general principle in everything in life, we've talked about how things are usually more complex than they're portrayed. But on the other hand, if we're going to portray them, we have to boil them down to something that our minds, can understand. And the idea here is that every single session, I think it will almost seem to me to take more faith to believe in evolution than it would to believe in creation. But knowledge is power. We talked about Francis Bacon's pseudo-scriptural writings that's quoted from. And we should strive to know as much as we can so we can be not marginalized if we want to talk to our colleagues who start sort of trying to talk over us or above us with all their supposed science knowledge. And The verses I have here, I think, speak for themselves in that. And there's 4 general broad categories that we touch on with every single one of these sessions. Some of these categories more than others. The mathematical improbabilities of things that, as I say, were much more with when we talked about the molecules and the cells. Violations or misapplications of logic and scientific principles. Just features of supernatural design. And we called that irreducible complexity at one point. But just saying that how could this possibly have occurred because so many things are dependent upon it, and you couldn't have a partial, you couldn't have a partial eye. You have to have a whole eye, and then how along the way, and especially at the end, how there's contradictions of Scripture. So these are the sort of 4 categories we're going to cover here today. First, we'll just say a few things back on the misconceptions, really, of the strata. I mentioned before how the strata were really circularly defined, which is to say that the rock layers were named by what fossils are in there, and the age of the fossils are determined by the rock layers, and the rock layers, it's a circular definition, so that you can't just look at one thing and say this is how old it is. And I thought it was rather interesting that these strata, the geologic strata, were first constructed by creationists 150 years ago to affirm catastrophism. Interesting to me, because then the evolutionists have taken this and used it in a different way. Things like periods and eras and other divisions were later added to this column. And the thing also is that the strata are not universal. They're missing in many areas. You would think if this is the way it should be the same in Antarctica, like it is in Africa, like it is in Europe, but it's not. And the strata are not always in the same order. We're going to talk about a couple of those things. And the rock layers, therefore, really are not diagnostic. The term diagnostic we use to mean characteristic or defining of any of the strata or any systems. And the strata we've mentioned before, and we'll go over a little bit again, they're really unreliable for dating for a variety of reasons. And we can show some examples tonight on how things that look like they are very old could have formed or did form or were witnessed to be formed very rapidly. And therefore the ages of things just can't be reliably assigned. And the thing that always made me the least happy about geology was there's a lot of extrapolation, a lot of theory about how this happened before that. And same thing really with archaeology, but I mean, there's some truth to what's going on there, but just it's not an experimental science, so to speak. It's very difficult, with some exception. You can't really reproduce any of the theories. And the other thing to just keep re-emphasizing, like we did last time, there's really not a logical progression in the fossil record to depict simple cells, so we just say the amoeba, to more complex like us. So here's just a couple of quotations from evolutionary geologists. This guy Eldridge, who's the works for the American Museum of Natural History, says, we got a problem here. If we date the rocks by their fossils, how can we then turn around and talk about the patterns of evolutionary change through time in the fossil record? Okay, so it wasn't they're not two independent things that happen to be parallel. And this other Cambridge University geology says it cannot be denied. Geologists are arguing in a circle. Okay. This guy Lamberts, I'm not really sure of his background, but it was quoted from Christianity Today saying, I have in my own files a list of at least 500 cases that attest to a reverse order in that supposed geological record. So what are fossils? We've talked a bit about it. They're preserved remains, impressions of once living things. Just a little show and tell. If anyone wants to look at it, somebody gave me this fossil, so I brought in a fossil so we can touch and feel. I don't think you can very easily break it. Remember Fibonacci's numbers from earlier? The spacing of the circle here is nicely demonstrated. So anyway, and fossils occur in anything that becomes like hardened, especially when it's hardened under pressure, like amber, rock, petrified wood, sediments. Usually under pressure or under high temperature. And examples are hair, bones, shells, exoskeletons, microbes, any of these kinds of things. And just so we know the terms, paleontology is the study of fossils. Anthropology is the study of man. There's a couple other ologies, but paleontology is the key word here. And as I said, it's usually formed by being buried or mineralized, but it could be buried quickly under high pressure, such as in a flood situation. And again, we'll talk about some things that seem to be more likely about that. So the second point here is we're going to go through in more detail. This will be the largest subsection to demonstrate evidences for a young Earth, because of course evolution depends on the Earth being 4.7 billion years old or something, and The Bible is pretty clear that somewhere in the order of 6,000 years old. I mean, maybe you can there's wiggle room up to 10,000, but several orders of magnitude away from what evolution theory says. We're going to go over some dating methods again. We covered a little bit of that, but how they're contradictory to old Earth findings in many, many, many ways. We're going to give many demonstrations of things that look like they're old, but they've been observed to occur in years or decades. I'm going to go over some data that show how sediments and things of that just don't fit, and the logic doesn't fit. So radiometric dating, I told you previously, and the one that most people are familiar with is this carbon-14 dating. And what it is up in the upper atmosphere, nitrogen, which is like 78 or 80% of our atmosphere, gets reacted upon by a neutron that sends out a proton. The point is it makes an extra number. It's the same atomic number, but it makes same atomic weight, but it adds an extra atomic number. So that's where carbon-14 occurs. And carbon-14 is actually only 1/1,000,000th of the amount of carbon-12, and carbon-13 is like 1% or something like that. But the reason this is important is that all living things will incorporate whatever carbon that's there. As long as it's a living thing, it's going to be interchanging. It'll turn things over as your cells divide. It'll get new carbon. It'll send the dead stuff will fall away. But once something dies, here we go. I'm not be able to put it. There we go. The carbon-14 will then decay back to nitrogen-14. So the ratio of carbon-12 to carbon-14 will go back to the normal range. And the decay, the decay is in a recognizable way by a mathematical equation. If you solve for the t in this equation here, an exponential decay, you can tell because you supposedly know how much you had to begin with and how much you have at the time that you're to begin with and the time you have, and you know the k, so you can tell how long it's going to take. You can calculate the half-lives of how long it takes for half of things to go away. But the reason I go into a little bit of detail here is that carbon-14 has a half-life of like 5,700 years. And it's a very general principle just because of the clarity, the accuracy of measurement. Once you get beyond 5 half-lives of anything, you really can't measure it as accurately because it gets too small. The differences are too small. You're used to seeing spots around a line. A line gets drawn, but then there's so much variation. You can't measure much more, therefore, than, say, 5 times 6,000, 30,000 years. So if something's older than 30,000 years, when we're just saying hypothetically here, really carbon-14 wouldn't be very accurate. There's other radiometric methods that have been proposed for measuring older things, like carbon, krypton, argon, uranium, lead, but they're calibrated in ways that are at least suspect. And we know that some gases can go both ways, but we know that some of the gas can leak out. I don't know if we have to worry about radon gas down here, but radon gas is something that's a uranium sneaking out of there. And there's other ways that things can happen differently that would change the way that these things are calibrated. So I think it's fair to say that these rock dating systems are not rock solid. However, the most highly regarded isotopic system for long dating is this uranium going down to lead. And I can't even pronounce the names of some of these kinds of crystalline rocks that are there, but the point is that the argon goes to all the way down this cascade, and every time it goes down this cascade in a nuclear decay, there's an alpha particle, which is to say there's a helium nucleus that gets emitted. And they can measure very, very accurately to within a very small fraction, because of mass spectrometers, the amount of what is getting emitted. But there's a lot of assumptions that you don't really think about or you're not told about, that there's no radiogenic lead to begin with, so that all the lead theoretically the radiogenic lead has been a product of this decay. But there's many, many examples of older ages in rocks by one system than with another system. So again, these are not rock solids. An interesting story here is this so-called, probably some of you have heard about polonium radiohalos. And what that is using that same system I was just describing, these alpha particles come off the uranium as it goes to lead, and you can measure these, but you can, more importantly, they come off at a different time, so they migrate at a different rate. And this diffusion of these helium atoms can be plotted, and it's actually more consistent with a short term of them of them emitting rather than a long-term, in other words, a creation versus an evolution model. And the distance, because the distance they travel, if you can extrapolate from the distance they're supposed to travel, again, it looks like more like 6,000 years than several million or billion years. So the data that are out there, the facts, do fit a theory of creation better than they fit a long Earth creation. And as I said, these radiometric dating systems have many different assumptions, that there's a closed system, that there's no radioactive species to begin with, and the constant decay rate. But on the other hand, when there's higher temperature, higher pressure, such as in a flood or a volcanic situation, then that can influence the speed with which this happens, which can essentially shorten the measurement of the decay. And neutrinos, we mentioned neutrinos before. They're this little, I think they have some mass, but they're these tiny little things that get sent out mostly to us from the sun. And when there's high solar activity, there's more neutrinos. And if you were up here close, you could see there's neutrinos in a lot of these different reactions when the quantum physicists work out some of these reactions. So you can imagine if there's a lot of extra neutrinos, that can slow down, or if there's not as many, it speeds up the rate at which those decays happen. So the point I really wanted to drive home, because we're going to go into it here, is that if you're going to use carbon-14 dating, whatever you're dating, it can't really be older than 30,000 or so years. But we're going to see some things. I'm going to call it this new wood in old rock supports. There's this canyon or creek area in Colorado that's been a gold mining district evidently for 100 years or more. And there's rocks from a volcanic complex that have been dated by like 32 million years. But guess what's in the middle of them? Some carbonized fossil wood that's dated to only like 41,000 years. So here we've got carbon dating and this supposedly standard measure of old rock dating of carbon, krypton, and argon, several orders of magnitude different. So something's rotten in Denmark, right? And contamination sources were ruled out in this particular one. There's many, many other examples of this organic material being found in rocks that are supposedly much older than that. They should have long ago decayed, the carbon-14. Not to mention the organic material itself should have all broken down and been destroyed. Uniformitarian theories have, in other words, evolutionists have a lot of ideas for how this occurs, but they just don't really hold up. They're not really well accepted. So just a couple examples. Here's a supposedly 100 million year old bee encased in some amber that was trapped, amber is trapped tree resin, right? And the pollen and parasites that they extracted from this measure a very short period of time because it's an organic matter here still. So how can the bee still be in 100 million year old rock? 40 million year old bee being dissected from amber because of bacterial spores and some other thing. A magnolia leaf's been found in a supposedly 17 million year old shale in Idaho. A T-Rex bone, there was evidently actually enough protein that they could actually sequence this. And the sequencing resembles only centuries old age from changes in the, not 70 million years or so, which is when the dinosaurs supposedly lived. And by the way, I said something that wasn't 100% correct last week that I occurred. I said that the T-Rex is a carnivore. And about a third or 40% of the dinosaurs were thought to be carnivores. And so I was technically right in that most of the dinosaurs were herbivores, but there's a higher proportion than I realized that actually are carnivores. So I don't mean to put any wrong information out, but that was an error from last week. And then there's another example of fossils with cartilage in it. In England, there's some bacterial DNA and some salt crystals that were dated at 425 million years old. There was very little difference in that bacterial DNA from modern DNA. And there's at least 85 reports of some soft organic tissues being found in fossils that are supposedly very old. And again, this is not a creation journal. This is a secular journal. So, other dating issues. Well, they say glass meteors coming from outer space. But they demonstrate a very highly variable rate of dating. And by the way, the best thinking of the age of the Earth doesn't come from trying to measure the age of the Earth, but rather measuring the age of a meteorite with the assumption that the meteorites, the asteroids out there, came at the same time as the Earth's development. Okay, so anyway. We've mentioned this before, dendritology, in other words, tree ring counting. The oldest is this Methuselah in an unmarked place somewhere in bristlecone pine in California, and there's sequoia trees that are only 3,200 years old. But this number keeps coming up as a coincidence of about 4,500 to 6,000 years old. Ice layers, because every year, certain stuff can form on top of the ice, and then a new layer of snow and ice, and then some other resins or residues or whatever can die there. So a lot of times they'll take cores. They're doing this in Greenland, I think, and they can make predictions that, well, if each one of these is a year, then certain things that happen at certain layers. But they find out that you can have multiple layers in any given year. I mean, you can have 2 snowstorms in one year, right? So the secular view is that ice sheets are really millions of years old, and they were first, as I say, done in Greenland, in the bedrock. But there's a lot of things that are inferred that are not accurate. And shorter, quicker formation can occur, especially when we know that there's no melting in the deep layers. But the thing that was the most interesting to me is they found in these rock layers that were supposed to be very old World War II planes, because they used to use Greenland as an air base to land, evidently, to bring supplies over to Europe. So it couldn't be too old if it was World War II. And other evidences, there's a lot of different areas when you look at lava, coming out from volcanoes. If you measure how much volcanic lava is coming out, if you extrapolate that back, we should have the whole entire crustal volume, our whole land mass should be covered if our Earth was really 5 billion years old. And obviously we're not walking on lava everywhere. Salt in the ocean accumulate rates would suggest, shall I just say, only 50 million years old, not 5 billion years old. So, I mean, a lot of these numbers are high. They don't fit into a 6,000, but they don't fit into a 5 billion either. So, and there's reasons why they could be older or longer. Solids in water are the proportions of certain solids in waters are more consistent with a younger age. I showed you an example, maybe that was just last time, of a coral reef that was growing on a sneaker. I think that was in Australia. So they say that they're too thin, coral reefs are, and unbranched to be more than a few thousand years old. Again, not millions to billions of years old. Ocean sediments and ripples are more consistent with a short period of time. The boglands, they measure the sediments and they say they're consistent with a shorter period of time. Comets, a lot of times they'll say, well, the comets, they have this water tail. And there's probably not as much water as we first thought in comets, but we'll talk more on that next time. But they should be melted after a certain period of time, because the comets are flying around. They're always melting. They're melting at a known and measurable rate. They should have melted long ago, but they haven't. So they must be young. Many examples of things that look like they're old but have been witnessed, as I mentioned earlier, to have occurred quicker. Luray Caverns, when you go through there, you talk about, oh, well, this happens at like, I don't know, a couple of millimeters a year, so it must have been many millions of years for these caverns to occur. These are stalactites and stalagmites, and they go by the name of speleotherms. I think I have that on a slide somewhere here. But there's this one particular cavern in Chattanooga that they've been known to grow at 1 foot per year, these stalactites. So they can grow very fast is the point. Also somewhere near Chattanooga, another one, within a couple of decades, they were known to have formed from nothing. Western Australia, the Lincoln Memorial, actually. If you go look at the Lincoln Memorial, down over on the side, you can see they have a window there, if you haven't, any of you been there recently, and it shows the stalactites and stalagmites. Within 45 years of them being built, they were 5 feet long. So under some circumstances, these things can grow quickly. They're actually growing from some bridges. One particular railroad bridge in Philadelphia was seen to grow 1 full foot in 56 years. And in Yellowstone, there's around some hot springs also, 1 foot per year they're growing. So they don't grow at millimeters. They don't have to grow at a few millimeters per year, and therefore extrapolate to being something that's old. Caves, whether they grow from the top down or the bottom up, is people who discuss these things. There's a lot of discussion of that I'm not qualified to talk about, other than to say that they've observed that things can grow. These caves can occur much more quickly than the theory of evolution would predict. But What about metamorphism of rocks? We've probably learned that, rocks under high pressure can change their characteristics. Shale is soft, it can turn into marble or what have you. But that's supposed to take many millions of years. Yet there's examples, this one area up in northern Norway, where these rocks were transformed to granules in a relatively short period of time. And it could even be much shorter if there was different temperature and allowing for the inaccuracy of the dating, like just maybe a few thousand years as well. In Connecticut, there's a region of what appears to be, in the process, observably quick metamorphism of certain schists, as they're called. Large, rapid water flow can really do amazing things. So we're going to start zeroing in on a theory for how some of this might actually occur. I may have mentioned this Canyon Lake Gorge in Texas that occurred within just a couple of days, this fairly large, 50 feet and 100 in just a few hundred years. Guadalupe River, that's somewhere down there near San Antonio. But anyway, the Burlingame Canyon in Walla Walla, Washington, in just 6 days, this pretty large canyon formed. So if you can see these things happening in days to years, this happened, in just a few days. Then why do we have to believe that it takes 5 or 6 million years for the Grand Canyon to form? We're going to come back to the Grand Canyon. So we're going to go right on to it. Evidence that the Grand Canyon formed rapidly are going to be following here. Thin layers don't necessarily take a long time to form, as it's been demonstrated. And a curious thing here is look at this rock. Look how bent it is. Can you imagine? Rock doesn't just bend. If it's hot or if it's under a lot of rapid pressure early on, that's when things bend. But once the rock is hard, it will be too brittle. It won't bend. It'll break. Yet we see this. This Brian Thomas, who's a science PhD, we see some prints here in the Grand Canyon that look like they probably were some kind of animal footprints in mud at one time. There's missing layers. Here's this author demonstrating that there's a gap between the layers here that there's no trace for the supposed 500 million years between two of the different things. And there's erosional surfaces that they can look at certain characteristics of these layers and say that some of them are erosional surfaces. But I think I did show this one before. The most, I think, indicting is that this one particular, I think I have it, layer here, this cardinal basalt, is way underneath the so-called unicaret plateau basalt. But this is measured by strontium measurement to be measured to be a younger layer than this layer. So something got upside down here, right? And also some wood has been found in various basalt flows. Again, carbon-14 dating says a few thousand years, but other dating says it's millions of years. There's generally a mismatch, whenever you can, between the so-called alpha measurements, which is what the strontium and argon, potassium measures, and the beta decay, which is what the carbon-14 measures. Now, here's an interesting thing. You must have seen this before because this is frequently is in this dried riverbed in Glen Rose, Texas in 1908. It was discovered that there's tracks of man and dinosaurs side by side. So if man is supposedly only 1 million years old and dinosaurs are 70 million years old, how come they're walking side by side? Okay. No other fossils were found around this, and over 100 tracks of this shared nature have been found over the last several years. They were surmising that because some of they have a large shoe size, maybe they're as much as 7 feet tall skeletons, and there were giants that walked the earth, back in Genesis, but who knows? This has been removed. You can't just go see this anymore. It's been, I guess, cut out for geological study. Now, Mount St. Helens volcanic explosion of 43 years ago is an interesting sort of little workshop, experimental workbench. Actually, it was only, they say, a medium-sized volcano, but it's the one that's been best observed and best studied because it occurred sort of right before our eyes. And we know that there was, within just a few hours to days, there was rapid formation of sedimentation that, again, gives the appearance of much older. And can you imagine the amount of wood that was blown away and burned and by mudslides was enough to build 650,000 houses. I mean, this was a pretty big scale, and this is just a little local explosion. This is not a global flood, which, again, I keep trying to tease you for that. But And there's a rock cap that blew off that was supposedly 350,000 years old, but it was known to be only 10 years old, or observed to be only 10 years old. These flooding and mudslides and hot lava vaporizing all kinds of ash and things that we're seeing. There's these upright logs that we're going to talk about in just a little bit. It makes a little bit sense that if there was such a rapid change, the whole big tree would be uprooted. And with the roots, they've got all this extra spaces, so wouldn't they be more likely to retain a lot of water and even the dirt, which is heavier than the wood in the trunk? So it's natural that they would be floating in water upright. And I think I have something, we'll come back to that. But in Spirit Lake, which is the lake just below Mount St. Helens, they've found rapid formation of peat and coal in only 20 years. Now, we've been told that fossil fuels take millions of years to form under high pressure and the like, but here coal was formed in only the 20 years after this explosion. And again, I emphasize this is just a small little local volcano. This is not anything approaching a global flood. So this so-called floating forest hypothesis, the coal formed quickly, the creationists would believe that there could be a bunch of organic material that just simply floated, whether it's be through flow or roll off, runoff, or what have you, as opposed to always being in one place with over a long period of time sedimentation occurring. But and this is what I was saying, that when they see tree fossils that are supposedly many, many years old, they'll many times see these sort of vertical tree fossils. And it fits with there being a rapid sedimentation or flooding as would be with the flood. So there's similar patterns found in many other places. So this is what we see there. Now the other thing that I think, we worry about, this global warming, we're ruining the environment, and of course we shouldn't ruin the environment, but there was all these fish and birds and everything that got killed, and when it first happened, Jimmy Carter was president. He described it when he went and visited, the sympathizers in state and chief have to go and look at things and have their photo ops, and he described it as a moonscape. And he had very gloomy predictions, as did everybody else, that this would never, ever recover again. And yet within 3 years, most of the species had returned, and here is the death and destruction, and just, 36 years later, it's essentially you wouldn't have known it happened. And I can remember myself, as today does happen to be the 31st anniversary of Hurricane Andrew, and I used to live over in South Dade. And when we saw what happened to the hurricane, we said it'll never be the same. But within 5 years or less, you wouldn't have known there was a hurricane that went through, except under certain areas. But so it's a testament, I think, to God's creation. It's very resilient. It's regenerative, if He wants it to be, and He does. What about petrified wood? Petrification is the replacement of wood with silica or opal. So that's why this looks like wood, and probably was wood at one point, but it's had minerals that have come in and replaced the cellulose that's otherwise making the tree. And that's what actually petrified wood. Well, it so happens that we saw rapid formation of petrified wood at Mount St. Helens and also in Yellowstone. And it has been demonstrated in a lab that you can build it, you can make it reproduce petrified wood within 25 hours if you have the high pressure and temperature circumstances necessary. You can make it form very much more quickly. And there's examples that have been demonstrated where these deposits have formed in just a few years. Petrification has occurred in just a few years. And there's many, many other examples of findings more compatible with a young Earth, many more sort of areas of consideration. Helium. Helium is supposedly formed in this, I showed you earlier, the alpha decay of uranium. So you can measure out how much uranium there is and thorium and how fast it gets. It should have only taken about 2 million years to get the amount of helium that we currently have in our atmosphere, according to uniformitarian calculations, not 5 billion years. The helium influx, though, can occur, and that would reduce this estimate even more, and to just a few thousand years. Again, Nature, not a right-leaning journal, a very respected, facts-only type journal, and they agree with that. Cosmic dust is out there, right? And it's estimated to occur at this certain rate, and if you calculated 5 billion years at this rate and divided it by how many pounds of dust it is per cubic foot, we should be in a 182-foot layer of dust around our world. And we're not buried in cosmic dust, okay? And furthermore, cosmic dust is very rich in nickel, which is rare in the ocean sediments, for example. Season flushes it into the ocean. Because if it was, you'd expect to see a lot of nickel in the ocean sediments, and you don't. So, now, this is too small to see, but this is a page from a book that I think is really an important book. That's not one of the ones I brought this time. Henry Morris, we'll talk about him a little bit later, was the founder of the Institute in Creation Research. And this is from one of his books, Biblical Basis for Modern Science, demonstrating 68 different things that are just measuring what the sediment or influx or outflux of certain things should be, and getting thousands to maybe a couple million years, not 7 billion years. So a lot of things don't make sense. What about the moon? Well, there's a lot of people, the leading theory is that something crashed into the Earth and that made the moon, and it came out of the Pacific Ocean. And, again, that's just talk. I don't think we have anything that we can say other than just that it's a theory, and the hole in the Pacific Ocean is maybe big enough to have produced a moon. But here's some interesting things. The moon is actually getting further away from us at about 1.5 inches per year. It's currently 240,000 miles away. If we wanted to calculate that, what's called the Roche limit, the moon could not have survived if it was closer than 11,500 miles, or else there'd be tidal forces from the Earth that would break it up. It would not be a stable thing. So the maximum the moon can be is 500 million years, not, again, 5 billions. And moreover, tidal friction is slowing the spin rate down. So again, if you make the calculations, it couldn't be 5 billion years old, or else the Earth's shape would be very different. And this guy from MIT, he writes, the origin of the moon from an impact is highly speculative. So this is the leading theory, or is a theory that gets print, at least. But here's another one, the decay of the Earth's magnetic field. Whenever there's movement of charges, there's going to be a secondary magnetic field, right? That might have been why you had the buzz you were talking about earlier, Bill. But at any rate, and we know that if there's electricity going through, there's going to be a magnetic field. So what causes the Earth's magnetic field has been thought to be that there's a solid core, and then there's a liquid outer core that's, as the Earth is rotating around, the solid core is not sloshing around at the same rate. So there's a difference in where those charged irons or nickels or whatever they are floating around. So it was first measured in 1829, and actually the fact that there was a magnetic field was first measured in 1829, and then Gauss is the first one who observed it, although not in the Earth, because their magnetic field becomes important in a bunch of other theories of other celestial bodies. So that's where the dynamo theory that I just described to explain it came from. And we're not going to go into that, but so it's been measured that the half-life of the magnetic field is only about 1,400 years. It's been measured to be decreased by some 14% since it was first measured in 1829. And that implies that if we went to 7,000 years ago, the magnetic field with uniformitarian assumptions would be 32 times as strong as it is right now. So it can't be. Why? If the magnetic field was too high, what do you think would happen? Our heart conduction wouldn't work. We'd have all kinds of awful arrhythmias. We couldn't have neural transmission of our nerves, so we wouldn't be able to live. So the upper limit by measuring the uniformitarian assumptions of magnetic field is about 7,000 years. So another thing is this: if it was too high, the cosmic irradiation would have been diverted, causing a shortening of the radiocarbon cycle. So there would even be shorter time estimates from the dating systems that I described earlier, because we wouldn't get all those neutrinos and other things that were coming on, because the magnetic field would have diverted them even more forcefully than it does now. What about the age of the ocean? The idea here is that from evolution, it's a rain of comets that melted, that struck the Earth and have sequentially melted. Well, comet water actually has a lot of deuterium in it. Deuterium is, H2O, means the hydrogen has one proton. But deuterium is when you have one proton and one neutron. It's because it's one proton, it's still hydrogen, but it's an isotope of hydrogen, it's got two. Tritium has got two protons and one hydrogen. That's necessary for hydrogen fusion bombs. But anyway, so they found that that's the case because they were able to measure from this comet. But our oceans, if this was the case, should be filled with deuterium, but there's no deuterium. And deuterium is very stable. It doesn't decay. It's not radioactively decayable. And that's from the NASA website. So Stephen Austin, who I'm going to quote later with Richard Humphreys from the ICR, also figured out that salinity increasing and ocean cooling is not consistent with a Big Bang formation, just from some models they put together. And the ocean sediments are too thin. Again, it points to a younger Earth. If the Earth was many billions of years old, you'd expect the sediments in the ocean floor to be much thicker than they are right now, because all this erosion has occurred over all those billions of years, and it hasn't. It should be about, the mean thickness of the deepest ocean sediments is about 2,100 feet, but it would or should be like 38 miles thick if it was 1 billion years old. So if you compare that, the volume of the continents is a certain size. We shouldn't have any land after 14 million years if there was a uniformitarian progression of that. So now we're going to move on to the third part here, evidences of design, just a couple of cycles and some things that we have that we maybe take for granted. I've talked about water before. It's necessary for life. There's no other alternate universe that we've identified yet that has anything more than, just a little bit of water, and there's no other alternative system that's ever been identified. I mean, if we're H2O, is there H2S somewhere? Although they have seen H2S on some planets, but there's nothing else that has any life basis has ever been found. In fact, 70% of us is water. You must have heard that before. We got some bones and skin, but that's just ways of holding together the water. And some 67% of our Earth's surface is water. And it's the unshared electrons. I don't want to get too wonky because you guys didn't like my chemistry one too much, but the molecule itself is really crooked. And because it's crooked, there's a little extra partial charge at the end of the oxygen. So really, water doesn't just float around as H2O. It floats around with a bunch of lengthy parts of it. So the H of one molecule will be drawn to the minus because this is a little positive charge, and it'll go to the minus of the other. So you'll see them all kind of capping, and they'll go around together in a group, is all I'm trying to say. And because they go around together in a group, we might call that, they have charges. That's why water will bead up on a nicely waxed surface. And there's a lot of different characteristics of water that you don't take a lot of thought of, but it's because of the basic structure, these unshared electrons. And that's also what helps a lot of other metabolic and chemical reactions, similar to what I talked about a couple of sessions ago. And I mentioned before that one really cool thing is that when water freezes, it starts to float. And therefore, lakes, when they freeze, there's still liquid under the ice. And that's a good thing, because if it froze uniformly, then all the life that's in the ocean or in the lake would die. You wouldn't have any fish the next year. But you still have fish under there, and that's why these intrepid fishermen can do this in the minus 10 degrees or whatever. Oh, I can't imagine. I can't even fish in regular temperature. I can't imagine sitting there. But anyway, and the other thing that's cool is that snowflakes. You must have heard of this. They have this hexagonal structure. In other words, six points to all of them, and supposedly every snowflake has a unique shape in them. So the hydrological cycle, sort of the step up from the basic building block of water, we might take that for granted. Water is really an ideal solvent. I said before, life is impossible without it. There's a cycle, though. And generally speaking, the water evaporates from an ocean. We get a bunch of humidity in the air, and then the humidity will hit some cooler land forces. It will, or scrape against the mountain, and it will precipitate, and it'll nourish all the land that it falls on and get gathered together in a river and fall back in the ocean. So there's a cycle. Some of the water goes into the ground, and then the groundwater can get into the ocean as well. So there's a cycle, and the Bible has a lot of things about the hydrological cycle in it. So that'll be there to write down if you want, but there's all kinds of things, wind currents and dust, balancing of the clouds, and conditions for rain. And water is used as a regenerative symbol really throughout Scripture, right? Baptism and things of that nature. But also water can be used as a judgment and even weaponized, right? Noah's flood, hailstones, how the serpent tried to carry the woman away with a flood of water, but she escaped. God protected her. And a curious thing is that there's no need for the sea, at least, and presumably for water in the new earth. But yet other places in Scripture it says that the earth was built to last forever. So I don't have that one figured out. If somebody else does, tell me theologically that. But anyway, Earth's atmosphere. Earth's atmosphere is a fairly unique thing to the Earth. A lot of planets, moons, other things, they don't have any atmosphere at all. The moon has no atmosphere. And again, we'll talk about some of those things the next time. But what's the advantage of an atmosphere? Not only does it keep oxygen that we can breathe, not only does it help us produce carbon dioxide, which makes our plants grow, right? Because the more global warming, the faster the plants will grow, so the more we can eat, anyway. We digress. But it protects us, therefore, from UV radiation. A lot of things shield out. You know how when the astronauts come back, they have to come back into the Earth's atmosphere at a certain angle, or else they would bounce right back off into space. And if I'm very bad at storytelling, but I understand it, the first time that there was a re-entry of the atmosphere, they go through the Van Allen belts where there's a blackout time, and then they didn't know whether they were going to be able to get home when they went out, but they did. So the physicists calculated things out right, even back then in the 60s. So now there's the evolutionary dogma is that the atmosphere that we know today was more anoxic, didn't have much air in it, so it was oxygen, so it was a reducing atmosphere, initially filled with these kinds of things. But then when did it switch over to be able to support life? And they based that on noting that a lot of supposedly old rocks have reduced components in them, like pyrite and uraniumite, and other things were lacking in there. But when did it change, and how could it change? Somehow or another, it changed to allow us. If they're proposing this, then they have to figure out a way. How did it change to support life? Which, by the way, must have been 1 billion years ago or something, because they say for a couple billion years, bacteria were the only living things on the Earth. But the nitrogen cycle, again, something we take for granted, right? I showed you before how nitrogen is a key component in every single amino acid, therefore in every single protein in our body. 78% of our atmosphere is is nitrogen. Only 20% or so is oxygen, and less than 1% is carbon dioxide, and way less than that is other things. So the nitrogen gets fixed by certain bacteria. I think I pointed out to you how bacteria do a lot of positive things for us, probably more positive than negative. And when it gets fixed, then it gets grown into the roots of plants, and that's how it gets into the plants that are eaten by either people or other smaller animals that get eaten by people eventually. So there's a recycling of nitrogen is the point. As I say, it's a necessary building block for all organic matter. And here it is, nitrogen was in this. This was the general formula for an amino acid. And so again, there was complex biochemical systems from very early on in what evolutionary theory would say was a pre-life period of time. So we're going to devote the last few minutes to really trying to countenance what we've just seen with how it would fit with the flood. And it actually fits pretty good. So uniformitarianism, I think I've mentioned this before, has really pretty much failed. And even evolutionists are pretty much saying that, well, okay, I guess we can't do uniformitarianism to explain this. But to back up a little bit, uniformitarians got to start really with Lamarck. He was the last of the naturalists before genetics, and he's the one who would have thought that if the one generation has a certain characteristic, then it's going to somehow pass into the next generation without having any understanding of what molecular genetics or anything would be. So saying like a blacksmith with strong muscles is going to pass that on to his children and their children, and they're going to get stronger and stronger, and that's the cycle, the engine that drives evolution. There's all kinds of other consequences, as we said, of this uniformitarianism that didn't fit the theories. Thomas Dewey, he wanted to totally change education systems, right? Engels, in eulogizing Marx, he stresses that communism as a social consequence. He says, just as Darwin discovered the law of evolution in organic nature, so Marx discovered the law of evolution in human history. And in a different context, Aristotle says that the notion that there could be nothing that preceded something offends reason. So the point of all these is that it all gets to the same general concept that uniformitarianism can't explain even for evolution. So that's spawned this now newer, what's probably considered more modern evolution is neo-Darwinism, otherwise known as catastrophism or punctuated equilibrium. And we'll cover more of this when we have a whole section on this, but it's worth mentioning. And this was born of the idea of this guy, Velikovsky, who published this theory in 1950. And he also hypothesized that large comets were colliding with the Earth, and maybe that's how some of these geological things happen. But there's a lot of things to explain why there might be neocatastrophism going on, wobbling of the Earth, and things that we'll understand a little better when we talk about planetary motion. But it just seems, to me at least, that these theories are grabbing at straws. This is the one I happen to have come across, but at any rate. And so the term punctuated equilibrium was really, I mentioned Gould before and Eldridge I quoted earlier today. These are Natural Science Museum leaders. And anyway, so the flood, I keep saying, is very compatible with a lot of geology, and we're going to dive into that a little bit. And it is interesting that catastrophism has now been adopted by most evolutionists, so they're getting a little bit closer to the truth, okay? So let's just diverge a little bit from the Genesis flood from Genesis 6 to 9. When did it occur? It's been mentioned in many different civilizations. Peter mentioned it. A lot of geology that we'll talk about can fit it. Man's ages immediately decayed right after the flood. It, of course, was in the context of a corrupt world. When did it occur? According to Ushers, and we'll show it on a graph in a minute, it was about 4,400 years ago. But there's room that it might be a bit larger. There was no rain before the flood. The source of water, according to Genesis, was just the windows of heaven or a rain collapse or water canopies. There's many, many civilizations also have legends and stories that describe there being some catastrophic, even worldwide type flood. So the timeline of the flood, this is Usher, you're probably aware he's this archbishop in Ireland, who he was resisting the pressure that at the time, the ecumenism that was trying to bring Roman Catholicism. He was of course, wasn't everybody in the 1500s a Roman Catholic priest at the time. There was an attempt to try to bring Calvinism and Roman Catholicism together, but he was against that. And he published this chronology that, I read this, was 1,600 pages long in 1650. But anyway, so to put you here, the creation would mean we date that to about 6,000 years ago, and we date the flood to about 4,400 years ago. And as I say, I keep saying there's room for gaps here. There's theological questions that maybe could double that interval, but we're not talking millions. We're just talking a few more than 6,000, maybe. Again, debatable. Some different reasons why that could occur. But compare that to the fact that evolution has to have billions of years in order to explain the theories that have been spawned by evolutionism. They can't compress evolution as a theory into even 10 or 20,000 years. It just can't. There can't be enough to happen. There can't be enough in several billion years, mind you, but there certainly can't be enough, and they know it, in 10,000 years or so. But creation can, and not only can it doesn't have to have only 6,000 or 10,000 years. Creation can be any. God could have just taken as little or as long a time as he wanted to create it, right? So what were some of the conditions in the earth before the flood? Well, there's this talk about this water canopy, water's above the firmament, and the outer atmosphere could have been much hotter. So it could have been that we were even more humid then than we are now. It was universally, presumably, a tropical climate, type climate, because the fossils are actually pretty similar worldwide. So there would have been, in Antarctica versus the equatorial regions, you still see these leafy fossils of leafy trees and rainforest type things. And so there was like a super greenhouse effect, seemingly, at that time. And possibly there was a higher barometric pressure, maybe more oxygen being made by plants, and maybe that's why people lived longer, because you hear about going into a hyperbaric chamber to fix an infection or to try to live longer and get more blood, hemoglobin in your blood. So maybe there was natural hyperbaric chambers in the whole world at the time, and maybe that's why people were living hundreds of years old. But there was no rain before the flood, interestingly, and there was little or no volcanic activity before the flood until there was the breaking up of the Great Deep, which will come there. As I said, evidently most life was longer also because it was mostly vegetarian earlier on, at least. And so we're going to talk in more detail. Now, the springs of the sea is, I think, an interesting example of how it was in the Bible, but men didn't know about it until more recently. So Job 38:16 says, "Hast thou entered into the springs of the sea, or hast walked in the search of the depth?" When he's excoriating, Job for his lack of faith at that point. And so there, you can do some word studies on these things, and fountains of the deep is very different than regular springs in the Hebrew, evidently. And it was later demonstrated. Not until the late 1960s did they find in this, well, I thought it was before it was discovered in Baja, that was actually discovered here in this rift off of Ecuador. Only in the last 50 or 100 years was these things discovered. So here's the fountains, something that sure looks like something approaching the fountains of the deep that were written, thousands of years ago. So they were probably established at creation, or maybe they got opened at the time of the flood, but a little more than that. So the wisdom, this is just an example of the wisdom and power of God demonstrated. It was essentially a fulfilled prophecy because we discovered something that he spoke of. And there's another example, this guy, William Maury, who talks about the circle of the earth, the currents in the earth. He discovered the trade route from southern United States over to Europe. And he discovered it because of the verse that he read about that. So now, some features, and I think I have a slide on that when we get to it a little later in another session, but some features of the Genesis flood. Now, I just thought, if you're going to read one book, this was a seminal book. This was written by Henry Morris in like 1960, I think. Do I say it up there? And this is an early, 1961, there you go. And he's the one, he was a geologist, and I'm going to talk more on him a little bit in another session as well, but he's the one who really put this on a scientific basis, explained the possibilities and the feasibilities of how the Genesis flood really probably did occur, and it's not just like a little kid's cartoon, right? So we know that Noah and his 3 sons with their wives, only 8 people were on the flood, and took 2 of every clean kind, 7 pairs of clean birds, or of unclean in the 7th. And sometimes you think, oh, the flood was 40 days, right? I'm sure everybody in this room knows it was really lasted over a year, because there was the time that they were in there for 7 days before it rained, and then they say it prevailed for 150 days. Now, does that mean it was still increasing over the 110 days after the rain stopped, or whether it's just that it's peaked and stayed that? I don't know. But then the wind started. This is clearly the beginning of the decrease of the flood. And you can follow all kinds of verses, and you can figure out that it actually lasted a lot longer. So they were on there for a long time. But that's where the evolutionists say, aha, we got you. Maybe you could survive for 40 days, but you couldn't survive for 12 and a half months, could you? Well, you probably could, actually. And we know how it rose, 15 cubits upward. Could that just be above the hills, or the draft of the ark? Or was the topography of the world very different? Probably was, right, at that time. It probably was very different. And it came to rest at Mount Ararat. Now, there is a Mount Ararat in eastern Turkey, which I'll show in a minute, but it may not have to necessarily be the same Mount Ararat. But they've never been able to find it. There's rumors, and John Morris, Henry Morris's son, went looking for it many times, but never found any good archaeology of it. But the flood was God's promise to Noah there afterwards, right? The rainbow after was his. So you have to think, I showed you some pictures earlier of those pretty large-sized canyons and how they could occur just from a local flooding and runoff. So you have to just multiply that in the very big world by a lot more. So what I'm going to try to do is give you a few demonstrations of how the power of rapid, massive water flows and volcanic changes, tectonic plate movements, really would fit with this. Rain was not likely a big factor. Only, they say that if you condensed all the water that's in the atmosphere worldwide, it would only make about 2 inches of rain worldwide. Now we can get 12 inches of rain or whatever it is. Wasn't there someplace like 20 inches they had just 6 months or something ago? But at any rate, that's because it's getting fed from other adjacent areas. But if you added it all up, it's only 2 inches. So you can't get 15 cubits above, out of just rainwater. So you have to figure out that most of that water came from somewhere else. So a lot of big factors. We're going to get, and we'll get to that in a minute, I guess. There's a lot of hydraulic factors with the water moving, and that can move differently as water channels change, right? If you have a big water, the Venturi effect comes to a narrow area, then the water can move even faster and be more erosive. Temperature and the quantity of water can matter. The slope, the angles of the slope, the soil types, however much groundwater is there can make big deals. The intensity of the rainfall, the intensity of the gradients of the air masses, the sediments, the size of the particles. All this stuff is very compatible with the formation of all these canyons. And it was probably fed, though, mostly by the release of, maybe likely under a lot of pressure, by these fountains of the deep, by underwater stores, possibly collapsing of some crustal climates, which we're going to talk about in a minute. Now, maybe you've heard of the tectonic plates, right? Those are like large areas of the crust. The crust is I think it's only maybe up to 20 miles thick around the Earth, and that's what we would call the land. But there's different plates that have moved around, and we're going to hypothesize that they moved around very quickly at the time of the flood. But they're large segments of the Earth's crust that shift, and when they shift and rub against each other, that's what causes earthquakes. And water earthquakes is what creates the power that starts a tsunami. It's when these edges rub, what's called subduction, with one plate rubbing underneath another plate, creates an amazing, they've calculated, I can't, but they can calculate the amazing amounts of energy. It might be something like, you must have seen these YouTube videos or yourself seen it. When you see these boats, they're coming in so slow, but the captain of that boat on a barge or something misjudged, and he can't stop the boat, and it crushes the pier and the land that it was coming into. So massive things moving even very slowly can create massive damage and massive pressures. So again, just keep your mind open to that being the case. Actually, I think this wasn't until about 1980 or so that this so-called seismic tomography was developed, where they can actually send like ultrasound beams down into the deeper layers, and they can get a sense for what's moving, what's not moving, how thick and how dense things are. Kind of like doing an X-ray, I guess, but I think it's ultrasound down. And so there's this so-called ring of fire, right? Not Johnny Cash's ring of fire, but a ring of fire in the Pacific, and that's why a lot of volcanic earthquake activity is along the west coast of the United States and over into the eastern coast of Asia. Here's the ring of fire in the Pacific Ocean. Here's Australia, Southeast Asia, North and South America. So it seems very conceivable, just on this basis alone, that this sort of a large process could have created these cataclysmic changes that constituted the flood, that made mountains, valleys, and all these other things that we now see, and have changed the topography of the world in a huge enough way that that's why the water was above and the flood was global and then landed. Now, I mentioned here that this continental drift really is when these tectonic plates move. And it was hypothesized centuries ago and reaffirmed by others or advanced by others that they noticed how, and you must have seen this before, that there's these kind of complementary sizes of the continents. And that made people think that there was this, maybe at one point, this one single landmass called Pangaea. And it's at the time of the flood, that's when all these things started moving in a fairly rapid way to form what we know of today. And we know that Europe is moving away from us at an inch a year. So it may just be that it moved, but it's now almost at a stop, but it moved a lot faster, maybe even meters per day at one point in time. And that could explain why there was all this uplifting, and the subduction could create volcanoes and all kinds of things that could happen with the earthquakes. The Bible talks about, in Genesis 10:25, as the earth being divided. So maybe that could be what we're talking about. And maybe they were talking about divided by the different languages. But I've read about this before, and I only came across it again recently. And I can't hold a candle to the proper explanation of it, but I mentioned earlier that the inner core of the earth is felt to be solid. And they know that because they know the mass of the earth. They can tell the mass of the earth by how other things interact with it, by that G/mm over r squared. Anyway, they can deduce the mass of the earth. And they have to therefore hypothesize, since they can measure some other things, that there's got to be a lot of heavy metals in that core, like nickel and other things, in order to make up all that mass. And then there's an outer core that's generally molten. And then there's the mantle, which is, I think it's like 500 kilometers or miles or something thick. And then the crust is on the outside. And it's not hard to say, and this guy Austin, with a big team from the ICR, physicists, geophysicists, computer modeling specialists, they had this huge model and the computer, and they could show how these tectonic plates could move, and when they subducted, they would force water down in one area. And what happens if you push, a basin of, not a basin, what I'm saying, like a hot water bottle, you push it here, it's going to bulge over here. So the same thing, if the one landmass comes over and pushes down here, then that means something else could push up over there, so you get mountains in one place and valleys in others, and there's this circulation, and it's been subjected to very high-level scientific inquiry, and secularists say there might be something to at least this model. Now, they're not willing to say that happened at the time of the flood, but at any rate, it makes sense. Now, what about continental distance? I'm not a flat earther, okay? We know that the earth is not flat, okay? But the Bible does talk about the four corners of the earth, and that happened, after the opening of the sixth seal. And could maybe some of these corners be in those extra dimensions of string theory I said earlier? I don't know. Here's an interesting thing, though, is that this is emphasized because the earth is close to spherical. It's really kind of crushed, but there's some bumps and booms. There's actually four protuberances in the otherwise circular geoid, as it's called, shape of the earth in these different locations. So maybe this is the four corners of the earth. I don't know. But another thing is that there's this thing called Lie theory, very high-level mathematics. Again, I'd like to read these things, but I can't fully understand them. And Lie theory basically is a way of describing or transforming curved structures, something like hyperbolic coordinate systems, into flat structures. And manifolds is when there's actually holes in the middle and it gets even bigger. So it might be that when we're talking about the four corners of the earth, God was already telling us about these other kinds of really high-level theoretical mathematics. But compare this to the pillars of the earth that Samuel is talked about in Samuel and Job and Psalms, and the foundation of the earth. Maybe they're talking about that there's the solid core. I don't know, but there's just a lot of things you might want to think and hypothesize about. So just to summarize the whole Genesis flood, what are the geological consistencies of the flood? Well, I've gone over them, but let's just summarize them in this slide. First of all, a lot of erosion from water flow, which is the consequence of huge underwater, sort of cistern-like releases of water that set in motion a lot of changes. Because actually the crust, I read, is actually more dense than the layer that it's underneath, the mantle. So once it's tipped a little bit, then it's going to sink a lot. And so maybe that's what happened, is the water got released, and then that tipped, and it got under, and that's set in all these different circular motions at the level of the outer core and the mantle that led to this. So then there was likely not only large tectonic motion, but fast, large tectonic motion, releasing, again, huge amounts of crushing to raise up the mountains, to lower the valleys, and lots of seismic effects. And then there was a lot of sedimentation, because what's going to happen when this hot steam comes out is it's going to precipitate a lot of water, so there'll be a lot of rain, or there'll be just a lot of water escape, and it will shield us from the sun, or all that ash will. We'll talk about that in a minute, because we can explain the Ice Age in this too. It also explains the formation of fossils, because the rapid burying of this catastrophic water and erosion effects happening. And it would explain why there's these misplaced things, that the dinosaurs are big. They can, like humans, they can maybe seek higher ground for a while until finally even the higher ground is underwater. So the current topography of our Earth could be very, very different. We know that there's these submerged islands, areas underground. If there was less water in the ocean because it was in the atmosphere, because it was somewhere else, that could explain why one species could be somewhere else in one place and not another. So this is just showing the cataclysmic kinds of things that might happen, the way mountains form, because there's these incredible crushing of energy from the tectonic plates. And these land bridges, famous land bridges, from Alaska over to Russia, maybe that's how the Native Americans got to our world. But earthquakes, I'm not going to belabor this one, but probably Noah's flood was a big earthquake with the release of these fountains of the deep. We know there's all kinds of other earthquakes for special times in Scripture, so it's easy to infer that there would be a lot of earthquakes at the time of the flood as well. And it's also interesting that they're supposed to, all these parameters have been increasing of earthquakes, saying that there's the beginning of the time of sorrows. But on the other hand, it might just be that it's cyclical, and we haven't been able to have accurate enough records back far enough to know that. So, okay, I mentioned Mount Ararat is where the Bible says that the ark landed, but it could be a different Mount Ararat than what we know to be Mount Ararat now. But the interesting thing about the Mount Ararat here, I'm sure you all know about it, is that Mount Ararat is along a fault line that goes right down through the Levant, right through Israel. And there was a big earthquake that happened just a couple of years ago. And maybe that explains why in Revelation it talks about Jerusalem being split. The great city was divided in 3 parts. Maybe there's going to be a huge earthquake because it's right along a fault line that, anyway. Other items that are more, the fossil column. I think I mentioned this before. It makes a lot of sense that the invertebrates would be at the bottom because they couldn't move. Then the fish, and then plants somewhere in there, and then the small-sized animals and the big-sized animals. And would also explain why, because they were moving. This isn't just that, boom, everything collapsed on them. They had a chance to try to scatter and get out of the way. And so that's what we're saying here. Coal formation, oil formation, all these other things, it's all consistent with that. We went over the petrified forests. And, so the fossil record is more consistent with the flood because of what I said, the smaller things would be trapped and as the seas were rising, and the bigger things would have a chance to try to climb up in the higher ground until they finally were also taken over. And that might explain why we have this column that is otherwise thought to be an evolutionary column, but it's just, I told you last time, it's like all your paper clips are at the bottom of that drawer, and your pens are in the middle of the drawer, and your pads of paper up at the top of the drawer just because of sedimentation. So we talked about mountains already, how they can form from all those pressures. And here's a really interesting thing. This guy's sitting on these huge, giant oysters, 13,000 feet high in the Andes. How did these big, giant oysters become giant in the first place? Maybe it was that high oxygen content. And how could they possibly be so high up in the mountain? Where's the water? Well, it makes sense that there's a lot of subduction and raising of mountains where there wasn't before. So it seems more compatible with the Great Flood. And there's a lot of other criticisms of flood theory, of course. And they're saying it's a local flood. It's not literal. It's a miraculous wall of restraining. There's a whole lot of different theories, and they're saying that the ark was too small. It couldn't support all that land. But if you add up how big it was, you actually could put a lot, especially if you use the word kind. It's like the equivalent of 522 real stock cars. And it's feasible that all the animal kinds could fit in because perhaps, 160 different animals are listed in the Bible. And so as many as maybe 1 million species or kinds could fit into that size. Enough room for 35,000 sheep-sized animals, some much smaller, some much bigger. And you know that reptiles, they could have been smaller, and dinosaurs could have been smaller because they keep growing. If you've ever been out there to the Miccosukis, you see these 20-foot alligators that are 120 years old because reptiles keep growing. And there might have been hibernation and So anyway, it's curious that there was these times of mass extinction, which again would fit with there being the global warming of the flood. But I wanted to get one more thing, is the ice age. There's a lot of theories saying there's multiple ice ages, or maybe there's one ice age. But the ice age could fit with what's been termed from, again, ICR has got this idea of the heat model, where there's a lot of heat with spewing lava. And remember, there was a big volcano explosion in Iceland maybe 20 years ago. And it was so dark from all the stuff that was just in the air there that the planes couldn't land and take off for a couple weeks or something like that. So is it easy to think that if we had, again, a huge event that occurred after the flood, that the whole world would get very, very cold, and any of the water would then precipitate at the caps, and we'd have ice, we'd have glaciers that would then make their way down, and then eventually maybe there's a sediment of all that stuff. Evaporation would make the cooling, and just the evaporation itself could make cooling, right? That's how you get your swimming pool cooler in the summer. You get a sprayer, and the heat of evaporation will take some of the heat out of the water and put it into the air. Aerosolization could have lasted for decades, and maybe that's why there was just such a cold period of time, and it makes sense. Dinosaur extinction theories, I'm not going to go into details here on this one, but there's a lot of thoughts and ideas, but it makes a lot more sense that it's a catastrophic flood that killed all the dinosaurs, along with a lot of other things, right? So here, we're almost done here, is Occam's razor. I don't know if you've ever heard of this terminology. It's a principle of logic, is that usually the simplest explanation is the correct one. Not always, but usually. If you can explain something with simple steps, it makes more sense than constructing a more involved step. It's also called the principle of parsimony. It's not deductive, it's just an empirical finding. This guy who was a Franciscan friar back in the 14th century. And Isaac Newton also saw its merits. He says, we're to admit no more causes of natural things than such are as both true and sufficient to explain their appearances. Therefore, to the same natural effects, we must, as far as possible, assign the same causes. Similar to what I've also heard called the KISS principle, keep it simple, stupid, And that's really was the underlying theme in Mies van der Rohe, who's an architect and designer of the 20th century, who pioneered this minimalism stuff, whether it's in houses or chairs or, instead of those puffy, pillory couches, they have just the simple things. And so what that's leaving us with is the unique Earth, setting the stage for man, right? Most planets have a barren surface. Earth's the only one with life, the only one even adapted for life. It only gets a small fraction of the energy of energy that the sun puts out, but that's enough, can you imagine, 35,000 horsepower per person. So we get a lot, we get plenty of energy from the sun. If we were further away, we wouldn't get that much. If we were closer, we get too much. Then we talked about the miracle of water, the miracle of air. The features of design are much more consistent with the Creator, which we'd have to think that this Earth is specifically created for man and man alone. And that's the end of geology. Thank you. Are there any questions I can try to answer? Yes?
Have you heard about the earthquake, or actually it was a volcano, in between Fiji and New Zealand that was under the ocean that put all the hundreds of thousands of gallons of water in the air in January 2022? Because I Googled it.
Sounds like I should have, but I can't say that I have.
It's a real thing. It really happened because they talked about Mount Pinatubo and all the other things. But that's the reason. Because of the canopy, there's so much more flooding in places where there weren't, and there's so much more humidity, and the reason why there's more heat. It's not climate change.
Well, that's a whole bigger talk. There's a lot of other reasons why climate change is contrived, but
For man, we
yeah,
know that.
right,
But
right.
that's something I just learned about recently, and I found it fascinating.
It is fascinating. What's fascinating to me from your saying is that's only over there between New Zealand and Australia. Imagine a whole cataclysmic world happening. It's just, if you can think big enough, which I usually can't, but it certainly seems to be in the realm of reasonability and logic for that to happen. But we can't prove it one way or another. But the model, that fast model is really, again, Google it up on YouTube, and there's just all kinds of stuff. And this fast model is really a key thing. There's been lots of scientific papers, and it's gotten wide acceptance outside of creation circles. So. All right, next time we're going to talk about the solar system. Okay, and all the amazing things. I mean, how big God is the solar is I think the theme of the solar system. And after that, we're going to get back to man, and then Scripture. So 2 weeks from today is the next one. Thank you.